Hi there, my beautiful students. Welcome to our screencast on ANOVA. So let's start. A good idea is always to start by reading our question. So we'll start there. An organizational developer or an OD in the government decided to do a comparative study looking at the earnings of middle management across more than one government department as well as across different earning brackets. And that long sentence there is complicated, but that gives us our first clue. This is looking at data on using more than one factor. The first factor we will consider is the government departments, and the second factor or another factor that we'll consider is the earnings brackets. Now I want to point out at this point that we're speaking about, when we talk about the earnings bracket, when we read here we'll see the OD narrow down the earnings bracket that the middle management in the government fall in as level 7, 8, 9 and 10. But the word level in that case must not confuse you. All of these four levels is one factor under consideration. Those are levels within a particular factor. And then the levels in the other factor would be Department of Premier, Department of Education, Department of Health and Department of Agriculture. And we'll be able to see the results displayed in table 1, which is this table over here. When we scrutinize this table, we'll see that there are 64 individuals that this OD looked at. And for the 64 individuals, he broke them down into groups of 4 in each of the two factors. The one factor was the earnings brackets, namely level 7, 8, 9 and 10, and we see that he managed to get 16 individuals in each of the different groups in the factor which is the earnings bracket, and then he did the very same for the factor which is the different departments. So we can also work out averages. So for the level 7, which is part of the factor which is earnings brackets, we have an average. For level 8, we have an average for level 9 and 10, and we can do the very same thing for the departments. So now we continue reading the rest of the question. That is the extracted ANOVA table is displayed in table 2. So we have an ANOVA table that's been constructed for us, and we're all familiar with what an ANOVA table looks like. We know that this is the data that's been broken down, but we know that the important part for us is this section of the ANOVA table. So in this section of the ANOVA table, which is the source of variance of the ANOVA, we're going to use the information that's given to us here to do our calculations. So when we look at this information given here, we have SSA, SSB, SSAB and SSE. These sum of squares, you're never going to have to ever calculate this in reality. In your class notes, there are the formulas. So if if someone has really been difficult and wants you to prove to them that you can do it, you know that you can do it and you'll be able to show them how to do it. However, what is important to us is we know that it comes from the variation. This is variation that we see as a result of the fact that we've divided our data into these groups which are within a particular factor. So SSA, it says on the side here, and Excel gives it to us like this. It has sample, then it has columns, then it has interaction. The sample is SSA and the columns is SSB. Now the columns tells us that'll have to be the departments. So the factor B, the variation as a result of factor B, would then be the variation that we see as a result of the departments. The variation that we see as a result of the earnings brackets, and the earnings brackets are labeled level 7, 8, 9 and 10. The variation that we see there is SSA, or the variation as a result of the first factor that we're going to look at. The important rule that we must remember about the sum of squares is that SSA plus SSB plus SSAB plus SSE is always equal to SST, which is the total sum of squares. And knowing that helps us to then calculate what any of these are if given the other four. Also, what we're going to then do to solve this question is we're going to get the mean squares. And the mean squares is calculated by taking the sum of squares for each of these factors, dividing by the degrees of freedom that is associated to that particular sum of squares. Let's go up and look at our question again. Let's finish reading our question. Using these tables, determine at 0.05 level of significance if there is evidence in the difference in the groups and factors involved by following the instructional steps listed below. So the instructional steps would be these questions that we are given, and because this is only a 15-minute screencast, we're not going to be able to do all of these questions in one screencast. So I'm thinking the best thing would be to explain the questions and then to also calculate the unknowns, and in a follow-up screencast we can do the detailed calculations. So let's start by looking at the questions. For factor A, there's a set of questions which is state the null and alternate hypothesis for factor A, then calculate the relevant test statistic and calculate the relevant critical value, and then state a conclusion, which we find it falls within what we know about the way that hypothesis testing is done. The same thing gets done for factor B, stating the null and alternate hypothesis, then calculating a test statistic, determining a critical value, and then making a conclusion as a result of seeing what the relationship is between the test statistic and the critical value. And then there's a final test which we know is the interaction test. Also an hypothesis test, so a null and alternate hypothesis must be stated. Then a test statistic must be calculated, and then a critical value is calculated or read off the table, and a conclusion is made. Okay, now the next thing that we need to do is to calculate the unknowns. We remind ourselves of what we do know, and what we do know is given to us in this ANOVA table. We know the sum of squares, we know the degrees of freedom, and the degrees of freedom comes from the number of levels in a particular factor, or the number of groups within a particular factor. Factor A, we've said, is the earnings brackets, and there are 4 levels within factor A. So the R that is indicated over here is the indicator, or the R in this case would be 4. The C, which we see belongs to factor B or SSB, is also the number of groups that we'll find in that factor, and it is coincidental that in this case the number of groups that is in factor A and factor B is the same. So in this particular example, R would be equal to 4 and C would also be equal to 4. But say, for example, if we did not have the Department of Agriculture, so if we had deleted this column over here, then the number of levels within factor B, or the number of departments, would then be C. So C would be, it would be 3, so C would be 3. But okay, forgetting all of that, as is, R is equal to 4 and C is also equal to 4. So the next thing that we need to do is calculate our unknowns, and our unknowns would be the mean squares that is associated to each of these factors. So MSA would be the mean squares that is associated to factor A, and we use SSA divided by the degrees of freedom R minus 1 to calculate MSA. We do the very same for the factor B. We'd use SSB divided by the associated degrees of freedom C minus 1 to calculate MSB. To calculate the interaction, we would use the variance that we see as a result of the interaction, the sum of squares as a result of that interaction, which would be SSAB, divided by the associated degrees of freedom, which is R minus 1 times C minus 1, to calculate MSAB. And then to calculate our critical value, let's not go ahead of ourselves. Let's first calculate those unknowns. So I've prepared a little table here, well, not actually a table, but some columns here or rows here for us to do our calculations. So MSA is equal to 936054875 divided by, and we said that this is associated to that, and R in this case is equal to 4. So that would be R minus 1. R minus 1 is 4 minus 1 is equal to 3. So that should be divided by 3. And that will give us an answer for MSA as 312,018, 2917. So that is the one unknown calculated. The next unknown we need to calculate is MSB. Same principle applied. So 1164,146,125 divided by the degrees of freedom. I'm not exactly sure what should happen there. The degrees of freedom that is associated, let me just get my pen back. The degrees of freedom that is associated to that would also, because C is also equal to 4, it would be 4 minus 1, which is equal to 3. So that would be divided by 3. And the answer for MSB would then be 3,808.7083. Right, we're only halfway there. We've got 2 more unknowns to calculate, which is MSAB. Same principle, 368,851.5 divided by. So this would be 3 times 3, if we know that that is 4 minus 1, and that is also 4 minus 1. So that gives us an answer of 3 for that calculation, and 3 for that calculation is equal to 9. So that would be divided by 9, and the answer there is 40983,5. Okay, the last thing we're going to do is calculate the error. The degrees of freedom here would be 4 times 4 times the number of replicates, and we have the number of replicates as 4 over here, because we know that in each group there's 4 replicates, so that would be 16 times 3. And the answer of 16 times 3 is, of course, 48. And so MSE is equal to 49820.5 divided by 48, which will give us an answer of 1037.9271. So these are all our unknowns. Let me just highlight them. All of our unknowns. That is our unknown. That's important. Let me start from the beginning. That is MSA. Important that we calculate that. That is MSB is the next thing that we calculate. The next thing that we calculate is MSAB. Highlight that as well. And MSE. And once we have these unknowns, then we